amazing. Wow. I'm I'm impressed. So many of you came. But we made the roads nice and quiet for you, didn't we? So yeah, it's great to be here. I've never been to Israel before, and so I'm having a really great time. Oded and Kobe took me out to lunch this morning, and that's a picture of it. There's a lot of food. That was a lot of food. So yeah, I'm Dave. That's my Twitter handle if you wanted to contact me or anything. I live in London, so it's not that far away. I can always come back if any of you want to see me again. Just invite me. And I work on the Spring team. So how many people use Spring? Enough. Okay, that'll do. So yeah, I was one of the sort of early guys, I guess. I'm one of the remaining early guys. There's a few of us left from the old days. I joined in 2006, 13 years ago. And I guess things have changed a bit, like, because we were small then, and now we're big. But it feels to me like I've had the same job for 13 years, which is probably not something that many people do these days, is it? It's, I don't know. I'll probably retire from this job. I'll never do anything else. It's great. I love my job. Anyway, I work on the Spring team. I write bits of code. So you might have, if you're using Spring and you've read the source code, we always put our names at the top. So you might have seen my name a couple of times. I did some stuff on Spring Batch a long time ago. That was my first project. And more recently, Spring Boot and Spring Cloud and stuff that you might have used. And also, Spring Cloud Function. So functions are a sort of a new topic, I guess. And so it was, sometimes with Spring, we don't always provide, we don't jump on every bandwagon, right? We quite often wait for you guys, for the community to decide what's interesting, what's useful. So Spring is a very thin, actually, layer of integration between, your business logic and stuff that you want to do, like, the common Java libraries. And we don't always lead that process, right? We often sort of wait for the community to tell us what's important. But this one, we didn't wait. We saw functions and serverless sort of coming down the road and all the big cloud vendors jumping on board. So we thought maybe there's something there that we can do. And I'll explain, I guess, a little bit about the journey, about why we got into it, and why we created Spring Cloud Function and how it fits in with the vendors and our own products, Pivotal, and so the open source and also the commercial products in this space. So I want to talk about, definitions. What is serverless? I don't think, if you came here for a definition, I don't think you're going to leave with any sense of satisfaction, unfortunately, for you. But I can throw a few thoughts out there. I can explain some of the concepts that I've heard people talking about, expressing as important when they've gone on this serverless journey. And then I guess it's up to you, right? I think you should, if you're going to do this, you should probably decide what it is, why you're doing it, right? It's not just something trendy that you decide you need to do because it's trendy. Decide why you're doing it, and I'll give you a few good reasons, and some of them you can pick and choose the ones that you like, I suppose. So I'll talk about what serverless means to different people, including me. Although, and I should really learn to spell serverless, shouldn't I? Then I'll look at the platforms. So what platforms, very, very briefly, what platforms are out there? How can you deploy functions or serverless applications, depending on how you want to kind of position your code. Including one called Riff, which is Project Riff, which is an open source serverless platform written by some people at Pivotal, mainly. there are a few external contributors, but it's mainly a pivotal project. And it forms the basis of our commercial offering in this space, Pivotal Function Service. So if you wanted to write functions and deploy them on-premise, like instead of sending them to Amazon or Google or whatever, then this might be a good way to do that, Pivotal Function Service. And to tie it all together, because that's kind of where I am, right? I'm a Spring developer. I'll show you how to write functions and deploy them with Spring. I probably won't get time. I'm going to try and wrap up in under an hour, maybe an hour, including the demo, so that Oded has a bit of time at the end, and so that you can ask questions if you want to. But if there's anything that you're interested in that I'm not showing, or I didn't show enough of, just raise your hand and I can definitely respond. I can answer questions as I go along if I need to. So this is a sort of collection of ideas about some things concepts that seem relevant when you start talking about and thinking about serverless. And I do think that it's, Oded pointed this out to me yesterday, or the day before, I can't remember. I've given this talk before in different forms. It wasn't exactly ever the same twice, but I think if you went back a year, you would find all these concepts a little bit fuzzier. I think they're all starting to fall into place. So they might represent different views of what serverless is to different people, but as things mature, so it's still quite an immature space. I'm not going to pretend it's not. It's hot, but it's not a majority. Like nobody's doing everything in functions yet. Well, maybe some people are, but they're probably kind of insane. That's taking things to a logical extreme. But things are maturing a little bit. Things are firming up. People are starting to get ideas and latch onto them, and we're no longer as guilty as we were maybe a year and a half ago of just bickering about the name, right? Serverless is a stupid name, obviously. Like nobody believes there's no server, all right? But there is sort of a reason why it's called that, so we might as well just have a look at it. So here's some ideas. The first one, serverless programming tends to be, event-driven. So data comes in, you transform it, data goes out. I'll talk about this more, I guess, later, but at least with the existing providers, right, Amazon, Google, Microsoft, I suppose, are the big ones. The characteristics of these events are really the flow, the business flow is request response. It's kind of what you're used to with HTTP, right? Incoming request, transform it into a response, and you might have side effects. Side effects are sort of, I don't know, so probably frowned upon depending on who you talk to, right? So I don't personally have a very strong opinion about this, but it's functions, remember, and functions sounds like functional. Functional programming has no side effects, so anything with a side effect is a little bit frowned upon, but as you'll see, one of the reasons you might actually end up using Spring is because you want to cheat and write a function with a side effect. Now I'm pointing out this thing about the input-output just because I don't think it's not really a very good model for events, right? Request response is very narrow, a very narrow semantic for input-output. What's more sort of general, I guess, is a stream, possibly infinite stream of events. Things coming in, and then you manipulate them, and then things maybe go out, right? And you might have 10 things coming in and one thing going out, or you might have one thing coming in and 10 things going out. There's not even a one-to-one mapping in the general case, all right? And you can fake some of that a little bit with some of the providers, like Amazon has support in their serverless offering Lambda for Kinesis. So Kinesis is in the Amazon platform messaging system, essentially. So you can send messages. And so that should be like an event stream, right? Messages are a stream of events. But the way they model it in Lambda is as request response. So it's kind of dumb, right? It doesn't really make sense. And you can make it perform better by having the request contain a batch of messages. Instead of a single message, it can be a batch of messages. But you still have to do batch of messages transformed into another batch of messages. So that's a limitation. I don't think that's a natural limitation. I think that's just been imposed so far by the implementations that we've seen, the platforms that we've seen. And we're thinking that Riff, because it's our pivotal platform, will probably not be constrained that way. We haven't actually got to that point yet, but we won't be constrained by the semantics of input and output being request response. Okay, so event-driven, it's important. Probably, but not to everybody. Another one that always crops up is this dynamic resource utilization thing and billing per message. They're sort of together, those two bullet points. And so that means basically if you write some code that you want to run in response to an event, that's great. But if there's no event, if nothing's happening, if there's no traffic, you don't want to run anything. And so you want to use fewer resources, I guess, right? So scale to zero is the sort of motto for this, which means, you shut the app off when it's not running. Why is this important? Well, it's important if you care about the billing thing, right? But it's a little bit subtle, right? Because if you're running this in your own data center, then of course the resources are still there, right? I mean, the servers are still there. There is a server. And somebody's running it, somebody's paying for it. So just because your app isn't using resources doesn't mean that those resources, that aren't being paid for by somebody. So, however, this is important, at least to some people, not to all people. In fact, not all of the serverless platforms out there actually even support this, so it can't be important to everybody. There's one in particular, quite common platform that doesn't support scale to zero, so it can't be important to everybody. But it probably is important for those people for whom serverless means get it out of our data center, right? Just get it onto Amazon, get it onto Microsoft Azure. Just get rid of it. Because then you really don't want to be paying for any code that isn't actually actively running, right? So that's important for those use cases or those business processes. The next one is the most interesting, I think, for a Spring engineer like me. So the focus, the promise of serverless is that finally you get to only write business logic. And hopefully I'll bring that out in the demo that I show in a minute. But you should recognize that, right? That's been basically Spring's message from the beginning, right? Even when I joined in 2006, this is what our training material was all about. You, as the developer, you write business logic. Let Spring take care of the rest. Have you heard that? That's what we used to say to everybody. So that kind of gave me some confidence that when we set out on this functions thing in the Spring team, we were stepping into some new territory. Nobody had actually asked us to do this, but I decided it was a good thing because of this, essentially, because it's the ultimate distillation of what Spring actually means, just to write the business logic and not care about anything else. This also sort of feeds into, I guess, probably what the next slide shows. But my big boss, James Waters at Pivotal, he likes to talk about this thing called the value line. It's a line in the stack that you use. So at the bottom, you've got infrastructure, like, bare metal, VMs, containers, whatever comes next, right? Application code at some level. And, then the business logic maybe sits at the top, I don't know. We'll have to discuss that in a minute, actually. But the message that James wants us to understand is that as you improve, I guess, or refine the abstractions, I don't want to use the word improve because it has a value judgment in it, but as you refine the abstractions that you use to deploy your application code, what you do essentially is you push the value line, or you push the value line up. You rise above it. So I say there's more stuff that I don't care about. The higher the value line, the less I care about below me. So I don't, as an application developer in Java with Spring, I used to have to care about the web server, right? The thing that I was running on, WebLogic, WebSphere, that kind of thing. I used to even have to care about whether I was running on, which operating system I was running on. Is it Linux, Solaris, Windows, whatever? I shouldn't have to care, right? I don't care. I really don't care if it's running on which version of Linux, which version of Ubuntu, whether it's got the CVE patches or not. With my DevOps hat on, with my operator hat on, I really care, right? I want everything to be patched. I want everything to be updated. But I don't, as an application, the application code that I write really doesn't care about those things. And I guess, one thing that serverless might be giving is the opportunity to push that value line up a little bit further even. So as an application developer, do I even care what version of Spring I'm using? No, I don't actually really. I might write it with Spring 5.1.7, but do I care if it gets deployed with 5.1.8, 5.1.9? I shouldn't care. I don't care. I don't know. There's another little analogy that I find helpful there. So as an application developer, what I want to do is I want to be able to build myself a nice little skateboard, right? Small thing with wheels on it that I can ride around on, do jumps and be agile, do cool stuff. But when it goes into production, I probably want it to be, a bit bigger, more sturdy, robust, a bit, more like a car or something. So I want to sort of take this skateboard and sort of wheel it into a big production line, and I want it to sort of trundle through, tests and pipelines and stuff and come out the other side, production ready, tested, definitely going to work in production. But it could have all sorts of things added to it as it goes through that. And you're used to this kind of thing these days, right? Everybody, well, not everybody, but at some level, you're probably all building a container as you move to production, right? You start with your application code. You end up with a build process that generates something else, and that gets sent to production. So how much of, that stuff below the application level do you care about? Me, not very much. In fact, as little as possible. So serverless is kind of helping you to care less about things below the business logic. Okay, which brings us to second to last bullet, platform services. All the existing platforms, Amazon, Google, Microsoft Azure, things like that, they have their own versions of services that you probably use in your data center as well, like, your MySQL database. You can probably get one of those from each of these providers. But they also have their own platform services, Amazon-specific things like simple messaging, simple notification service, that kind of thing, AWS, S3, things like that. And those can be very convenient, right? It's sort of a double-edged sword. Like the providers definitely want you to use those services, definitely, right? They would love it if you used more of them. So if they make it as easy as possible for you to use the platform services, then you will use more of them. And so therefore, serverless has been a way for them, I think, to sort of unlock more usage of their services, and it's not a bad thing, right? I mean, as a developer, those services might be useful. I don't think that's always a bad idea, but it is sort of a little bit of a lock-in game, right? So sometimes you're using stuff that you might not have an easy alternative to if you move to another platform. And so there are some things happening. I think this side of the market is starting to mature a little bit. People are starting to think about portability of services a bit more. What I've always concentrated on is just the code that you write as an application developer, rather than worrying about the service plumbing. So I think we might get more into service plumbing, but maybe not on the Spring side, maybe more sort of Riff or other things in Pivotal. The platform people will be more interested in this side of things. And finally, okay, what does it really mean? It's the value line again, I guess. Nothing to install or maintain. So this is kind of the the typical prototyping story. You have a business idea. What's the quickest way you can get it out there and doing work? Well, it's pretty quick to write, a Spring Boot application and throw it in a jar file and, deploy it to a platform of some sort. But I mean, it's probably even quicker, and especially when you take into account these platform services, like the services that surround you, it's even quicker just to write a tiny piece of business logic. You can even do it in these serverless platforms. You can do it like as a text box in a UI, a web UI. You just send JavaScript to the back end and it deploys it as an app. And so that's a really, really quick way to get an idea exposed to testers, users, right? That's great. And that old every time you build a prototype for something, you say, well, I'll just get it working and then I'll go back and, do it properly. Anybody ever do that? Yeah. And do you? Do you ever go back and do it properly? Well, sometimes you do, but the thing is with serverless, I think this is the story that I've heard from a few people who've got into this game. It was just too easy to leave it there. It worked. You stood some code up, it worked. You don't feel like you need to change anything because all you wrote was business logic after all. You didn't have to write all of the plumbing, all of the spaghetti behind it. So that was always the hard stuff to migrate when you did it properly. So that's part of the story of moving to serverless. So I spent too long talking about that, but hopefully that's given you some food for thought and stuff to think about. I'll quickly go through this just because it sort of underlines that value line discussion. So this is a visualization of that you can, people on that side of the room, I can't point at both windows at the same time. Maybe I can use the pointer. Does this work? Yeah, you can see that. Okay, so there's sort of a straight line in green going up through this diagram, right? And the diagram shows on the vertical axis, it shows increasing, I don't know what I'd call it really, granularity maybe. That you start with the hardware at the bottom, VMs, operating system, containers, runtime, so I guess that's Java, JDK if you're writing Spring applications, Node.js if you're writing in JavaScript. Application is like the business logic, I suppose, the way that things sort of interact, and functions are methods, things that transform data. And so as you go you have these levels of abstraction. So in infrastructure as a service, container as a service, platform as a service, and function as a service is sort of a function as a service is like a placeholder for serverless. Some people say it's not the same thing, right? Serverless and function as a service is not the same thing. I don't believe it is, but it's a good placeholder. Some people say that serverless is PaaS, platform as a service, right? I mean, you could make that argument, but I'm not here to claim one thing or the other. All I'm showing is that as you move the green thing around, so this is the customer unit of scale. This is when you write code, what do you deploy, what can you scale up and down, what can you remove from production, change the route to, that kind of thing. And there's something a bit interesting about this diagram. So one of the, it's obvious that it goes sort of up and to the right, this green line. But what's sort of interesting is that with FAS, you've left something, this application logic, you've left something which is in your control. It has to be, because it's your business process. You've left it sort of dangling, in fact. It doesn't really fit the abstraction, right? So if you deploy a function, it probably doesn't do enough on its own. You need 2 functions, 3 functions, 4 functions, and then you need to orchestrate how they work together in order to have a business process, in order to have an application. And there isn't, the origin of this diagram is actually a talk that I went to by Olivier Tadier from IBM, and he stole it from John McKim. And so he was talking about some alternatives in the FAS space to deal with this orchestration problem. So there are some people thinking about that. But it feels a bit awkward somehow. You deploy functions, but you don't get to, without, the platform doesn't actually support orchestration of them. And that's a bit of a weakness, actually, frankly, of some of the serverless, or all of the serverless platforms. They don't have orchestration, they don't really have observability in any real or, any useful sense, right? There are things that you can use to help you debug and trace what's going on inside your functions, but to see the big picture, like the application, the business processes, are quite difficult. So when I was preparing this talk, I thought I stared at this and I went a bit cross-eyed, and I thought, what if we just take these last 2 columns and switch them around, and then what if we take the top 2 rows and switch them around, and what would it look like? It would look like this. And I don't know, I haven't decided yet, but I'm giving this to you, something to think about. The green line is still linear and goes up to the right, but here now it sort of more accurately, to me, portrays the picture that in the serverless, in the function as a service, you leave the application logic out in the wild, right? That's something that you have to deal with, but it's above your unit of scale. And so this somehow makes more sense to me. It's maybe more accurate. And that, it is interesting, because then it puts PAS at the top of the abstraction layer instead of next to top. I don't know, sort of interesting, I thought. Anyway, so what would you likely be doing with serverless platforms? What kind of problems are you going to solve? Well, there is a Cloud Native Computing Foundation white paper. You can Google it, there's a link here, and I can make the slides available there. But that's actually quite easy to Google. If you Google that, you would probably find the thing that I'm linking to. And there's a section in that which is, I don't know, maybe 10 pages long, that has a list of really useful use cases for serverless, and some of them are here. And they've each got like a paragraph or 2 paragraphs describing them. So go and look at that. But the ones that sort of appeal to me straight away, because I've done it myself, are things like webhooks. So, an event, something happens, and somebody promises to send you an HTTP request. GitHub does it, right? If you have a GitHub commit or a pull request or something like that, you can ask them to send you an HTTP request, and if you make that endpoint available on the internet, then it all works. So that would be great. You could use a function for that, and the GitHub commit, it might be that you have 1 a day, or it might be that you have 100 a day, but you probably don't have 1,000 a minute, right? So it's not something that you need an app to be running the whole time for, but it is something that's quite useful to, respond to the webhook when it comes in. Background jobs, so the poster child for that is image processing. Everybody wants to have thumbnails. You download an image or you upload an image and you want to get smaller versions of it. So it's CPU intensive. You don't want it to happen straight away. You want it to happen in the background, and you want it to be eventually available. So that's a good use case for serverless, because you never know how many you're going to need and when you're going to need them. And sort of hand-wavy general glue code. So this is to do with basically, the job of the enterprise developer in the main is to do with transforming data in one form to another, right? Events come in, payment data or something, and you've got to transform it into a canonical form and get it into a system. So it always comes in the wrong format, doesn't it? And you always have to send it to, something in the right format. So it's a good use case because, it is sort of background. It happens in the background. It's like sort of ETL in some ways. What it's not, so what none of these things are, is latency sensitive. Right, so if you care deeply about, if you're trying to serve a JavaScript resource to a client, a browser, and users are going to have to wait for it, that's latency sensitive. You might not want to use a function to do that. There are better ways to serve static content, frankly, right? Just directories and web servers and content delivery networks and things like that. So anything which is latency sensitive is probably not a great use case for reasons that may become obvious. So this is the kind of picture you get. I borrowed this picture from Jan Kui, who does a lot of these things for real. I think he runs a gambling service, but he wrote it all in Amazon Lambda. So he writes good blogs because he solved a lot of the problems. And frankly, he's hacked around a lot of the problems that he's encountered in Amazon. So look up his blog because it's got a load of good stuff in it. And I just copied this picture just to give you a sort of visual impression of what apps look like when you start building them out of smaller and smaller pieces. So this might be a very simple business process, right? Just to do with, I don't know, some sort of onboarding process for new customers. Instead of an app with layers and stuff inside it, it's a big sea, a big cloud of functions, and some of them you will notice are connected to backends, message brokers, purple things, backends, Redis. So they're not entirely. Certainly, the Redis one is kind of what I would call a not side effect free function, right? It takes an input data and it puts some stuff in Redis. So that's a good example of somewhere where you had a really good tool that you wanted to use, you had a backend data store, and you just wanted to connect to it. And I think that's probably quite common. Okay, so a quick tour of screenshots. There is this service on Amazon called Lambda. It has a web UI, obviously it has an API as well, they're all API driven. So you can upload a zip file or a jar file if you're writing code in Java. There's one on Google Cloud Function as well. I think Google Cloud now has native support for Java. It didn't used to, but what I'm showing in the text box, if you can't read it, it doesn't matter. It's somebody typed in a Java main class, so you can type code into a web text area in a web application, submit it, and have it, run as an application in the back end. That's kind of the flavor of serverless. Microsoft Azure looks like that. It has this JSON descriptor thing, so that's what I'm showing in the screenshot. That's not actual code, it's more like a sort of meta descriptor of what the code is supposed to do, inputs and outputs and stuff like that. If you're writing code in Java, then they have an annotation-driven programming model for generating the JSON. So you write Java code with annotations and it generates this thing for you that I'm showing in the screenshot. Alibaba has one that's very similar. It looks very similar to Amazon, actually. So I don't know if they copied Amazon, but they probably were inspired. And they were probably inspired by Amazon, let's put it that way. And then we have, this is a bit of a cheat, this screenshot, because we don't have a UI. Riff is the open source project behind the Pivotal function service. And so it runs on Kubernetes. And that's just a screenshot of Google Kubernetes service cluster that's running Riff, just to show that it did. If I had a longer demo, I would probably show you just some code going to Riff. I think Oded might be showing some deployment of code, and it'll feel a bit like that. It's basically write some code and then a command line that pushes it into the platform. That's the simple idea. And you don't want to be, as an application developer, I don't want to have to deal with lots of YAML. I don't care about the descriptors, right? Because it's boilerplate, and that's kind of the way that the Riff CLI works. So it's just Kubernetes at the end of the day. Okay, so here's a list of providers. It's not even all of them. The ones that I knew about when I wrote the slide, if they had Java support, I put a J in the list. I think somebody told me that Google Cloud Functions now has native support for Java. The ones that don't have native support for Java, you can always run Java in some way. You can persuade it to do it because they all have like a custom runtime container contract thing, so you can write Java code as long as it meets the expectations of the framework. Generally speaking, that works. Okay, so that brings us to Spring. And what was I thinking? When we started looking at providing functions as a programming model for Spring users? So the obvious place to start was this Java util function package, which is in Java 8, right? So all modern Spring projects have a Java 8 baseline, so we can use that. And there are these three interesting interfaces. There's a function, which is a transformation, so that is like request response. There's consumer, which is void return, so it accepts input, but it doesn't have an output. So it's a bit like a post, HTTP post with just a 204 response or something like that. You accept the input, but you don't necessarily respond with output. And then there's this thing called supplier, which is void input, and then you get an output, and that's a bit like an HTTP GET. And so I've given you the HTTP analogy. There's also sort of a messaging analogy, and so at the time we were thinking about Java, functions. I had been working on Spring Cloud Stream, and has anybody used Spring Cloud Stream? I have, yeah, a few people nodding. So Spring Cloud Stream is an abstraction over messaging, essentially, message broker connections. So that if you want to connect to RabbitMQ, Kafka, Google PubSub, that kind of thing, you can write the code once and it will be deployable in different messaging transports. So it has sort of natively, it supports out of the box transformation called a processor, which is like a function, a source, which is like a supplier, so a source of messages, and a sink, which is like a consumer. So there was an immediate correspondence between these three interfaces and the existing functionality we had in Spring Cloud Stream. So we thought it was a good place to start, and that's what we did. I'm actually going to jump into a demo now. So I'm going to build a new Spring project. I'm just going to use Spring. No, I'm not going to even use web. I'm going to use reactive web to start with. No functions, no streams, nothing fancy, just web application. And that, by the way, was, in case you didn't know, was me using Eclipse and connecting to the Spring initializer start.spring.io. This is the new version of start.spring.io, and I just wanted to show you this because it's got a new button which hasn't come into production yet, but if you've ever used this site, that will be really nice. You can now you can generate the project and then browse the code in the browser instead of having to download it. It's kind of cool. I like that. That will be in production probably in the next week or so. Okay, so I've got my Spring Boot application. I'm going to make a REST controller. Everybody's seen how to do this before, right? Let's wait while it equilibrates. I'm going to do a post mapping so I can post HTTP data to it, and I'm going to say let's have a foo. So this is a simple POJO with a value. So it's a wrapper for a string essentially. So I'm going to say mono of foo. Mono is just a single valued stream. In case you haven't done this whole reactive thing. So there's a foo input, and so when I get a HTTP post request coming in, it's going to be a foo, and it's going to return mono.just new foo of foo. Oh, sorry, don't need that start. New foo.get value dot to uppercase. Okay, so the poster child for these function apps is always make a string and uppercase it. So this is a little bit like that, except it's going to be a JSON object that has a value that's a string that I'm going to uppercase, right? So to make that work, I need that to be request body. So I can just run this, and you all know what's going to happen, right? But I'll make sure that it does actually work. So I'll run as Java application. Should start up fairly quickly, and then I can curl it. So localhost 8080 -h. I'm not sure if I have to do this, but I'm going to, just in case. Application JSON, and then I'm going to say here's my input value. Do you remember foo had a value? Tel Aviv. It's like hello world, right? Okay, so that will -w. There we go. So it uppercased the value of the foo. Everybody see that? Yeah. Nothing, remotely interesting about that. I agree. That was awful. Terrible demo, Dave. Don't do that one again. No, there was a reason I did that. So the reason I did that was because I just wanted to point out that although, we've come a long way in Java, right? To do this, stand up an HTTP endpoint and post some JSON at it and get a response. To do that 10 years ago, does anybody remember how much code you would have had to write? A significant amount, right? And so there were some yaks to shave. And so we're doing well here. I'm proud of what we've done here. I was responsible for some of that, and I like it. It's made it fun again. But here's what I'd like to point out. This is the business logic, right? I want to get the uppercase value of foo. That's the business logic. Why did I need to tie that business logic to the HTTP transport, right? It's post mapping and it's REST controller. I kind of find that a little bit uncomfortable. So that's where we're going with functions, right? So what I want is I want to be able to do this. I want to take those things away, and I want to be able to, let's see, public. It doesn't need to be public actually, but it's kind of, it's part of the feature of the application, isn't it? So I want to make a function that transforms foos into foos. Does that make sense? Java util function. And I want that to be a bean because it's Spring. And then I guess I'll call it uppercase, that's fine. And then foo goes to new foo. All right? So that, to me, expresses all the business logic without anything about the transport. It doesn't tell me how the message is going to get there or how it's going to get out again. Unsurprisingly, this will now not work, right? So I'm going to need to do something to make it work. So the good news is I don't have to do very much to make it work. So what I need to do is I need to change the dependencies, okay? That's all I need to do. So that's to me, that's below the value line, really, right? I don't actually care about my dependencies. I'm going to have to specify them, but I'm quite happy for somebody else, if they want to do that. So let's just change the dependencies. So there's this feature in Eclipse that you can change the dependencies. So I'm just going to do it. I'm going to add functions. And because there's a bug in Eclipse, surprisingly, I'm also going to add another part of Spring Cloud, and then I'm going to delete it again, and I'll explain that in a minute. Why do I have to do that? Because if I didn't do that, then it wouldn't add this dependency management for me, and I wanted that. So I'm just going to remove the thing that I added artificially. So all I've added is Spring Cloud function web, okay? That was the net effect of that. And I'm going to run the app again. And remember, the app is now HTTP free. And now when I run it, it's about the same, a little bit different logging, okay? And it says something when it started up about a function catalog. So now it's picked up the fact that there's a function there, and it's registered it in some sort of registry for functions. And surprisingly, it's able to do what I could do with a post request, post response, post mapping in web. Okay, so that was a nice demo. That's much nicer, I agree. Thank you for the applause. I appreciate it.
What if you will do put request?
We could support that. We don't. It only supports post at the minute. But yeah, that's not a bad idea. Yeah, I haven't thought about that. We could add a configuration option for changing the request type to put. It supports GET because you can have a supplier. You can also do a GET. I'm not going to do it now, but you can do a GET with the string in the URL, and it will give you back the value as well. What I'd like to do, though, is something slightly mind-bending. I'm going to change the dependencies again. I'm going to go to Cloud Stream. I'm going to take away the reactive web, so I'm no longer a web application. I'm a messaging application with Cloud Stream and RabbitMQ. I could have chosen Kafka or any number of other things, but RabbitMQ has a nice UI, which I will prove. 15. Let me go 672. It's already running. I just need to log in. Guest. It has exchanges and it has queues, and exchanges are input and output, and those were created for me by the app that I just didn't run. Okay, I will run it. Run as Spring Java application. Okay, so slightly different logging on startup again, and you can tell that it has started to listen to Rabbit because it's doing stuff with channels and AMQP and blah, blah, blah. So what it's done actually is it's created these two exchanges, input and output, and there will be a queue with a name that looks like input. So that's the queue that's listening to the input exchange. So if I go to the input exchange and send it a message, I can test this assertion that I made last night. I did that if I don't add a routing key, it might do something interesting. Hello. Publish that message. Message published. Let's see if it showed up. So I've got this queue sitting on the output, which didn't get anything. Looks like it didn't get anything. Okay. I know how to solve this. So let's just check. Get message. Oh no, it's there, look. There it is. Oh no, that's the one from yesterday. Okay, purge. Purge and start again. So let's go input, payload, value, hello again, because I might get that hello eventually. I'm going to give it a routing key. Star worked, didn't it? Yeah, I was practicing this with Oded yesterday. So I sent that message, and did it show up on the collect? Yes, there it is. Okay, so it's popped in, and I can then receive it here, get messages. There we go. Hello again. So I'm sending I'm basically the app that I'm running here is now transforming foos to foos, but they're on Rabbit messages instead of HTTP. So that's a neat trick.
Why did you specify the method?
There's only one function, so it's unambiguous. So you can, if you have more than one function, you have to say which one it is. But there's only one, so.
How do you say it in annotations?
Configuration, so application.properties. Yeah. So the question, in case you didn't hear, was how do I set the input bindings? Let me see if I can work this out. Input, let's see, binding, Spring Cloud Stream bindings. That stuff.
Also for the previous one, also configuration?
Yeah, also configuration, but there's only one function, so the root URL goes to the single function. Yeah, if you have multiple, then you would have to specify which one. Yeah, it's just function.name equals or something. Yeah, okay, good. So demo pretty much over. I could go further, and so I'll show you on the slide, I guess, some of the things I could do. That's what I just showed you, right? The uppercase function. Actually, I showed it you with POJOs, so as function of POJO to POJO. You can also do this, so you can write a function that doesn't have any dependencies on Spring. All right, so I did one that was a Spring Boot application because I wanted to just kind of bootstrap it. But you don't have to do it that way. You could just write Java util function in its own package, and then there's a component scan. And component scan, normally you do it with that component, but you can also do it with interfaces, and so that's what we've done with plain old functions. Yeah, I mean, this is great if you don't want any dependencies, right? You really just have bare business logic that has nothing to connect to, and maybe that's a useful use case. Quick digression. So I measured some billing measures on AWS Lambda. The blue one. So this is just to show you, I think, that we've been working on startup time. So I did say that latency sensitivity was probably a bad idea if you're doing Lambdas, but it's improved a lot. Okay, so the way that Amazon charges you for your function is you say how many megabytes of memory your container has, and it runs the Lambda per request, and it counts how long it takes. So if it takes 1 second and you ask for 1,000 megabytes of RAM, that's 1,000 megabyte seconds, and you get, I don't know what it is, you know, a minute fraction of a cent per megabyte second. So they're quite cheap, but they charge you for more memory and more time. And so this is the vertical axis here is megabyte seconds. And the blue one is Spring Cloud Function 1.0, or 1.1 maybe. The red one is Spring Cloud Function 2.0, I believe. And the yellow one is a new feature in Spring Cloud Function 2.1, I think it was, where you can build a sort of lighter weight app. So the way that Amazon works is they have their own sort of Java runtime for Java code. You give them a function to run. They bring up their runtime. They grab the request. They feed it into your function. They grab the response and send it wherever they need to send it. With the custom runtime, basically they tell you what they're doing in that container. So they tell you what to do, and what you have to do is you have to start a process that does get from an HTTP endpoint to get the request, do whatever you want with it, and then post it back to another endpoint. So they give you basically the URLs for those two endpoints in environment variables. And that's actually pretty light, right? I mean, you could write, well, that's what I did for Spring Cloud Function. So basically the same app that I showed you with the app being uppercase, you can run that as a custom AWS runtime with just dependency changes and maybe a little bit of configuration. I can't remember. You might need to add something in application properties. And it will run in these small containers. It will run, look, about 8 times faster. That's quite a lot, right? That's a factor of 8. So I think it was probably 15 seconds in a half gig container with Spring Cloud Function 1.0. With 2.1 and a custom runtime, it's going under a second. So that's 2 seconds, under 2 seconds. So that's good. That's good news, and I wanted to share it. So we have a sort of a manifesto for Spring Cloud Function. We want to have all the things that you might expect from serverless, whatever that is, right? So there are lots of people who have different ideas about what serverless is, but hopefully they'll all find something in Spring Cloud Function. But you have full access to, number one, Spring features like dependency injection, auto configuration, all of that stuff, especially in case you want to do that cheating with the side effects thing. So if you want to connect to a backend database, for instance, then Spring is ideal for that, right? You know exactly what to do. You just add the dependency and then inject the data source or whatever you need to do. So there's sort of a spectrum, I guess, from plain old functions all the way to functions with additional dependencies that do side effects. And somewhere you can position yourself somewhere on that spectrum using Spring. And the other thing I think is important is it's all the familiar stuff that you're using for everything else, right? Your tests, integration tests, delivery pipelines. You can run it locally, like I was just doing on my laptop. All of that stuff is very familiar and very convenient for Spring developers. So we're used to that and we like it. So it's the same programming model for Spring developers using functions as anything else, but maybe a little bit more general. And for people who don't know Spring, you don't need to know Spring because you can just write Java util functions. So ultimately, and I think I demonstrated this with the web rabbit transformation, right? You can decouple the business logic from the runtime platform, the message transport. And I think ultimately, all those cloud providers are all a little bit different from each other. They all have slightly different Java APIs for their function platform. But if you're writing your functions using Spring Cloud Function, at least that part of the code is portable across providers, and that gives you a little bit of confidence, right? I don't think we can ever say that you won't get tied, you won't get locked into a vendor, right? I can't prevent that. I can't prevent vendor lock-in just by providing a few sprinklings of Spring annotations, but I can get somewhere close. I can provide at least the application logic bits of it can be the same everywhere. So I just wanted to mention quickly the idea that the signature for those functions that I'm writing, these things. I've had function of foo to foo. I could have foo to bar, obviously. I could also have function of publisher of foo to publisher of bar, right? And publisher is a reactive streams interface. And the ones that I showed you at the beginning were mono. I used a mono in my web app, right? So mono is a single or zero valued stream. A flux is in principle, infinite number of messages. So this is how we basically translate the more complex messaging semantics that I was talking about. So it's not just request response anymore. If you can write a function of flux to flux, then you're transforming a stream with arbitrary numbers of items into an arbitrary other number of items. It can be one to many, many to one. We're just adding in Spring Cloud Function 3, which is coming out this summer, we're just adding the support for multiple input streams as well. So you can have function of tuple of flux. Yeah, so you can have 2 input fluxes or 3 input fluxes or 4 input fluxes and then 1 output or 2 outputs or 3 outputs. So you decide, and the framework sort of works out from the signatures what you're doing. Okay, so that's coming. This is just a visualization of, I guess, the way the bits fit together. The blue thing is what you write. The green things are what I write. And the yellow thing is what the provider does. So Amazon, for instance, has their own jar file that you download and you include in your build time, your build dependencies. And so the idea is that the yellow bits can change. You might have to change the green one from Amazon to Microsoft, for instance, but basically the blue, which is the important thing, above the value line, is always the same. So, one last summary. We have a programming model. We've designed a programming model using Spring, so it's beans of type Java util function consumer supplier. And the inputs and outputs of those functions are fluxes, mono, publisher, pojos, tuples soon of fluxes, tuples of publishers, giving you quite a flexible programming model which is independent of the transport, okay, independent of the layer below the application. So we have a component scan for functions, which means you can do plain old functions. We have a sort of a party trick, feature number 3, which is kind of inspired by the existing providers, Amazon, Google, Microsoft. They all let you type code into a text box, right? And generally people do that in JavaScript or Python or something, but we allow you to do it in Java. You can just write the function as the body. So I could just write, foo goes to foo, new foo of value.getFoo.get uppercase or to uppercase, just that one line. And that would get compiled into a function and registered in the function catalog. And so you can have a sort of interactive experience, I guess, with a function app in that way. I call it a party trick because I can't imagine anybody actually using it in production, but please tell me if you do. It's there. We also have some features for isolating the function from the thing that's invoking it. And now they don't do that in any of the existing runtimes. So Microsoft and Amazon, for instance, they mash everything together in the same class loader, which is potentially problematic because they do use versions of dependencies like Jackson, right, that you might want to use in your own code. And so we want to keep these things separate. So in the Riff function invoker, there is a class loader separation. It doesn't cost very much. It's very cheap to start this Spring function thing. It's only got a tiny bit of code, so we don't need very much code in the isolated class loader. But there's some framework machinery for isolating the class loaders between the two. It might be interesting to people if they ever want to run somebody else's code in a Java environment. And then we have some adapters, actually more than the ones that are listed. Spring MVC, Spring Webflux, Spring Cloud Stream actually includes Spring Cloud Function as a dependency now, so it's kind of its own adapter. There's Amazon, Azure, Riff, IBM OpenWhisk. We host those ourselves, and then there are other providers that do their own integrations. So I think Oracle, for instance, the Oracle team working on Oracle FN have their own Spring Cloud Function adapter. I'm kind of out of time, and nobody asked me any questions. But you can, if you want. You have one last opportunity to ask a question, and then I'm going to unleash Oded on you. You have a question?
Yeah.
Good.
In your demo, most of the
The question is, when would I recommend to stick with a REST controller? I'm not going to make a recommendation. That's far too broad. You're grown up. You can make your own decisions about that. I think I would like to hear stories about this being used. Oded has a good one. He had was it Rabbit and switched to Kafka story? Yeah, so he did it. It's possible.
there's no trade-off. I mean,
Yeah, there's a trade-off. It's an abstraction. So you're leaving probably boilerplate stuff that you didn't care about. You're leaving control of that to the framework. If you ever wanted that control back, right? If you wanted to take control of content negotiation or anything that's HTTP specific, then probably you're in the wrong game. Yeah. Yeah. No, it's a good question. It's a good question. I don't mean to I don't mean to shrug it off too much. Yes.
So when we have
Okay. So the question, if it's a question, is from somebody who likes to use Swagger. I gather if you switch from REST controllers to functions, where can I get API documentation? I guess that's an accurate summary. I don't like Swagger much myself. I prefer to use Spring REST docs, and then I could probably continue to use Spring REST docs, and it would work just fine. So think about that. I don't know. I mean, like it's a simple transformation, right? From function to HTTP endpoint. Somebody could write an open API metadata introspector for the functions. It would work. I don't think it would be difficult, but I mean, like, if you like adding all those annotations to your code, then you might as well stick with REST controller.
If there is some way to solve it or not.
Okay, so the question, or I suppose the comment was that 2 seconds isn't a very impressive startup time, and it causes problems, latency problems for cold starts if a user in a browser is waiting for that function to run. Yes, of course it does. That's why I said that latency sensitive use cases are not very well suited to Lambda in general. And even less if you're running Lambdas on Java. But, you know, if you have a user who's waiting for it, then there's a content delivery solution. You know, there's a web application solution that's probably better suited to that use case. I believe, at least anyway. You know, something that would scale better. And people play games with functions, right? In fact, Microsoft, if you ask them, they'll tell you that you can pay more and they'll scale faster. They will literally tell you that. I've heard people from Microsoft say that. And how would they do that? Well, they'd, you know, keep a few warm copies lying around, right? I mean, yeah. So, you know, if you had a perfect autoscaler, if you knew when the traffic was coming, you could always warm up a few containers and get them running in time, right? The problem is that nobody's perfect, so you're always going to end up with a kind of latency tail. Even if the containers start up much quicker, it's still not going to be as quick as a live app that's been running and warm, especially if it's running on Java. Having said that, you know, the custom runtime, if you take that and compile it to a native image using this new GraalVM technology, that will start quick. That will start in like 10 milliseconds or so, and you won't even need 500 megabytes of container image for that. So there are some things coming down the pipe that might be interesting, definitely for lower latency apps written in Java with cold start times that are, you know, more like tens of milliseconds than tens of seconds. The other part of your question was, you said 2 seconds is amazing, especially if you start adding dependencies. And so, yeah, if you start, the more things you add, the more jar files you add, not necessarily the more jar files, but the more features you use. If you start using Hibernate and, you know, databases and messaging and, you know, backends and stuff like that, sure, classes, you load classes, it costs, that's like 80%. I do another talk on startup time. More than 80% of startup time in a JVM is class loading. So the more features you use, it's not necessarily the more things on the class path, because things on the class path they're lazily used, right? They're not loaded until they're used. But if you're using more features, you expect the start time to be less. But these functions are thin, right? They don't really depend on anything. You wouldn't put all of those dependencies that you would in an application into a function. You might be able to do it without Spring even, right? And then, you know, Spring isn't slow, but all the things that you start to suck in when you want to, you know, interact with back-end systems, that's the thing that will slow it down. So you could, I think, there's probably hope, basically. You could do a number of things that would make your experience better, but you'll probably, without native compilation, you'll never get down below. You'll get below a second latency. Like at the top end of that graph, it was below a second. It was just using a bigger container. So the thing about the Amazon runtime is they only give you one switch. You can increase the size of the container. And as you do that, they give you more CPU. And so it's a fact of life that the JVM, when it starts up quicker if you give it 2 CPUs or 4 CPUs. Ideally 4. If you try this yourself, you'll see, because with Docker you can run Docker minus CPU, right? And then you can see what happens when you start it with 4, 3, 2, 1, half a CPU. And by the time you get to 1, it's probably about that difference, probably about a factor of 10 or 15 slower than if you had the full CPUs available. So there's that to think about. And they didn't, when they designed the platform, they didn't give you the ability to ask for more CPUs. Maybe they would in the future, I don't know, but that would probably help as well. Actually, that's an unrelated topic, but a lot of people, when I talk to them about startup time, it turns out when we look at their app, they were running in a constrained environment, right? Their sysadmin had given them a VM with half a CPU, or they'd given them a Kubernetes pod on a worker that was only allocating a tenth of a CPU per app, and that really, really slows you down. That is horrendous for Java. It's not so bad for other languages because of they don't need so much thinking time on startup, but it's terrible for Java. Should we do one more? Yes.
This is a replacement for the Spring Cloud task.
Is this a replacement for Spring Cloud Task? Interesting question. We have an adapter for Spring Cloud Task that I didn't mention. We've thought about it. It's not a replacement. Is the summary? But we've thought about how you could apply it, because in the same way that a Spring Cloud function ended up being part of Spring Cloud Stream, you could imagine that it might become part of Spring Cloud Task. Yeah, they have similar concepts. On the stack. Yeah, it's true. Yeah, so a task is it's often a bit like supplier and consumer, or supplier function consumer, or something like that, right? That's like an ETL. Yeah. So you can actually do that. So that's one of the features we did build into the adapter.
So you're going to put both the functions and the tasks.
Yeah, so functions is a way to express a task. You can write an application that has a supplier and a consumer, and then add Spring Cloud Task to the dependencies, and it becomes a task, right? That's kind of the
because the task Spring Cloud is also a serverless.
Yeah, no, it's a very similar concept. You're right. The thing that somebody asked me if we should have, in addition to function, supplier, and consumer, if we should support runnable. And we've ummed and ahed about it. The interfaces we've defined don't preclude that. So somebody could do it, and we could take a look and see if it made sense, but we haven't done it yet. That's a bit like supplier consumer together, right? There's no visible sign of it running from outside, and you could turn that into a task really trivially as well. Yeah.